Okay, hello everyone. My name is Yasin Abidin Siam. I'm working as a backend developer in Blockbones team. So uh, our backend system actually a financial application which has been running in the backend in production system for more than 7 years from now. So it's more or less a monolithic type application, and recently we picked up a business domain from that monolithic application and converted into microservice, and which has been running into the production for more than 1 month. So today's session is about storytelling, like how our journey has been when we picked up that domain, converted into microservice, and how production deployment worked, and how our journey has been went through. So yeah. So during the session, I will try to cover up some of the topics regarding our journey, like what was the motivation factor that actually drive us to convert a particular part from monolithic application to microservice. Obviously, there has been some challenges during the journey, and how did we tackle them? And apart from that, also we actually integrated a gateway which actually benefited us in different perspective for converting into a microservice application. So I will also try to explain a bit on that part. And obviously during our journey, we had some learning curves, like what to do and what not to do. And yeah. Okay, so there are some things to consider. Uh, the approaches that we have followed to convert into a microservice application was actually specific to our project. There are some challenges because the system has been running into the production for a long time. So we actually did not have the fancy to integrate all the microservice technologies that are out there in the market. We obviously had to maintain some restrictions and follow some specific approaches so that our existing system works as expected. So the approaches that we have followed might not be best suited for your project. So you may find a different approach, or you may find a better solution when you start converting your application into microservice. So yeah, but today's KT session is mostly about our journey, what we approaches followed, and if you can take some concept from that, maybe you can implement it into your conversion part. Yeah. Moving on to the next slide. So let's take a look why we are calling our system as a monolithic application. Obviously, it's a very large application running into the production, but that's actually not the only motivation factor which actually leads us to tell that it's a monolithic application. Rather, our business domain was growing. There are new features coming. At the same time, there are new team members who are joining into our team. And obviously, when we want to actually release any new feature, we actually had to deploy the whole monolithic application, which obviously takes quite a long time. So those are one of the things that actually drive us to convert a specific part into microservice. And also we had our team members who actually need to work into different part of the project. Sometimes it's actually becomes a bit cumbersome. So if we have one part into microservice and have some of the dedicated members to work into a specific part, that thing we thought would be a good thing considering our project. So yeah, and obviously sometimes the application will had to be supported for large number of customers. So large number of customers, large number of requests. So obviously it will be better to start dividing the part by part into microservices. Yeah, moving on to the next slide. Yeah, so we did convert it into microservice, but obviously our motivation was not the fact that we have to follow the latest trends, because if you look into the social media or LinkedIn, everyone is talking about microservices, having a full-fledged microservice with all the patterns and technologies out there which can be integrated and have a full-fledged microservice. But that was not our case. For our case, our business was growing, so we need some scalability, obviously, and our team members were growing, so we need to consider the maintainability, dedicated resources per business model. So yeah, so if you are developing a small application, you may not need to consider converting into a microservice. Rather, you can just enhance what you have right now. So once we convert it into the microservice, is benefited us to achieve less build time and also having a proper continuous delivery mechanism. Moving on to the next slide. And obviously, during our journey, we faced some challenges. One of the things actually we thought was better to make a transparency with our client. We actually need to understand whether our client is ready to break an existing system into a microservice application. Because your client is smart enough to make a good amount of business with your monolithic application, then why you need to actually convert into a microservice? So these things needs to be discussed and be transparent with your client before you start working on that. And obviously, once you start the driving on conversion, there will be some performance lag, and it is better to maintain a transparency with your client and also have some plan how to overcome it. So for that, what we did, we initially created a POC and show a demo to our client and let them know what performance issue that we have compared to our existing system. And obviously, even if you consider converting an existing application into microservice, you must make sure that your existing system works as it is, because if you convert a particular part into microservice and found that some existing things are breaking, then I don't think it will be a good idea. And of course, we also discuss with our client regarding the time frame, like is it a tight or flexible? Will we have enough time for testing and make sure that all the things are working as it is after converting into microservice? And once these things are finalized, you also need to have a plan about your team structure, because the microservice will be more or less a separate project, and you will need some team members who will dedicatedly work on that. And of course, you will need some QA for that. For our part, we had 3 developers who were working on that microservice, and we had 2 QAs who were dedicatedly working on that. So these things we also discussed with our client when we started the journey. And yeah. Moving on to the next slide. So let's take a look how actually we started, or how did we do. At the initial stage, we first picked up a business model from our monolithic application. And how actually we picked up that business model? First of all, we checked how much client, obviously because this part is being used by the production, I mean by the real clients, so we obviously need to check the consequences. So when we picked a particular part, we checked how much real customers are using that thing, and we got notified that it is not being used by so many customers. So we thought that it will be a good part to convert it, because we will not have such, or we will not have many impact if the system was used by large number of customers. So For our case, we had so many things in our application because it's a financial application, and we picked up a module called loan, and we decided to convert it into microservice system. And once we did that, we actually listed down all the API calls, like how many API calls are there and how many API calls are being used by outside world from that monolithic application. And after that, we identified the database model. Let me explain a bit about that part, because obviously if you have a microservice backend system, it will be good if you have a dedicated database for that microservice as well, rather than communicating with our existing database. So we had to find out the database models, like which tables will be used by that particular microservice and what things we have in our existing database. So once we were able to find out the database model, we actually started moving the codes from old system to the new system based on the APIs that we have listed down from our monolithic applications. So yeah, and afterwards we actually separated the deployments. As I've mentioned previously, if we need to release a small feature, we actually need to deploy the whole system. So as our specific part has been divided into microservice, so we decided to separate the deployments part as well, so that if any bugs or any new feature needs to be implemented which has related to that particular microservice, it can be done separately and does not have any effects into our existing system. And also we considered to set up the team structure, like how many QAs will be working on that. In our case, the QAs actually played a good role, because they are the ones who will actually verify whether the existing system works or not upfront. So even after moving the codes, you will see that some things are breaking at runtime, but it is the duty of QA who will make sure how the systems are behaving compared to your previous system. And obviously the developers' duty will be to move the codes from old system to new system, but we'll take a look into a bit how we actually followed that when we start moving the codes. So yeah, we had a team structure, and then we checked the data sync thing, because in our production system, there are some live data which actually needs to be synced from our old database to the microservice database, because once we deploy the system into microservice, we actually need to make sure that our microservice works as expected with our existing data, since the business domain part was an existing system running in production. So we obviously made a plan for that, syncing the data or what we have into our production system and make them available into the microservice database, and test and verify that our microservice works with existing data as well and does not hamper in any part. So when we talk about data, obviously there will be some failures. You might get some different behaviors from your microservice. So obviously you need to have some fail-safe operations, because apart from data, even if you convert into microservice, you may end up in a situation where your existing application needs to be communicate with your microservice. So suppose at any point your existing system is not able to communicate with your microservice, then there will be a failure. And what will be the impact out there? Will the existing customer face any disaster things? So these things we also included in our plan and made some fail-safe operations. Moving on to the next slide. So now let's take a look into the diagram, what we had previously in our monolithic system. It's a typical Azure setup. In the leftmost part, you can see all the consumers which are making calls to our backend system. Our whole system was sitting inside a virtual network, and an Azure application gateway was sitting front of a virtual network. The diagram is not clearly mentioned, but yeah, this part, or the Azure application gateway part, basically sits in between the consumer or the virtual network. So what it was doing is it was accepting the request from outside world and then transferred the request into an internal load balancer, which is a thing that you need to maintain when you create a virtual network in Azure. And the duty of that internal load balancer is to redirect the request into our monolithic backend, which is this square you can see at the top right. So all the requests are being redirected into our existing backend system. And obviously we had one database and all the database related operations were happening from the single database. Moving on to the next slide. So when we followed all our plans regarding how we will convert the microservice or which part we decided to convert into microservice, we actually had this structure. So obviously our consumers were there, their API definitions were never changed. They were using the same APIs that they have been using before the conversion of microservice, and it's still accepting requests from Azure Application Gateway, and which was redirecting the request into the virtual network via an internal load balancer. And what we did separately is we actually placed an API gateway in between the internal load balancer and our backend. So in top right, you can see our existing monolithic backend, and at the middle, this is our microservice part, which we have converted. And this is the dedicated database for that microservice. So what application gateway will do is it will still accept the request. It will redirect all the microservice business domain related requests into the microservice backend, and all other requests will be redirected to our existing monolithic backend. So if I say it again, let's say, for example, we have converted our loan part into a microservice. So all the loan related requests or the responsibility of this gateway will be to redirect all the loan related requests into our loan microservice backend, and all other requests will be redirected to our existing monolithic backend. And obviously the existing backend will still continue to work with its existing database, and the microservice part will continue to communicate with its dedicated database. In later slide, we'll take a look further about this API gateway, how it actually benefited us. But for now, let's take a look into the next slide. Yeah, so this is actually a pictorial view, which I have just explained in the previous slide. So this is the application gateway that we created in between the load balancer and the backend system. It accepts the request. All the microservice business domain related request will be redirected to this microservice, which just been converted, and accept all the other requests. Say, for example, bank, user, and so on and so forth will be redirected to the existing monolithic application. So in case in future, if you want to, say, for example, convert the user domain from your monolithic application, the API is the responsibility of that API gateway to redirect the request into that user microservice, and keep the rest of other API calls redirected into the backend system. Yeah, moving on to the next slide. So this part I have already explained about the API gateway and the consumers and the API calls and business domain microservice related API calls. We still actually had some issues when we actually separated the database. We found some thing, it's actually specific to our project, that even though we have converted our microservice, there are some things or business logics which actually requires to update the data into the previous database. Obviously, those tables are actually not related to that particular microservice, but still they have some common data which actually needs to be application throughout the monolithic application or even in the microservice. So how did we do that? For our case, what we did, we actually created a DLL, or rather specifically, we can say that we actually created a shared repository. The responsibility of that shared repository would be to do the operations into the common database or the centralized database which has been used by the monolithic application. So let's say, for example, for an endpoint, if the endpoint needs to do some data operation in both the microservice database and into our existing database, then the repository which has been dedicated for this microservice will do the operation for its dedicated database, or the common data operation which needs to be done into the centralized database. The responsibility of that shared repository would be to do that. Someone just shared a feedback that I may need to zoom in a bit. Should I zoom in a bit, or it's clear?
It will be better to have zoom.
Yeah, I'll try that. Is it better now from previous, or I think this is the maximum I can do?
Feels the same to me.
Sam, it's the Google presentation, right?
Yes.
So you can zoom in from there in the option menu. There is a view, then zoom. From there you can zoom.
I don't think that will work when I start the slideshow.
I think we need to keep it like this.
And I think it will be better to continue with this.
Yeah.
Yeah, the slide will be shared with everyone, so I think it can be zoomed afterwards as well. But if you have any confusion regarding the image, or you need any specific clarification, just stop me during the presentation. I will just clarify. I will try to clarify. So, yep. So this is the part where we actually introduce the shared repository, which actually helped us to do the database operation when we have some operation that needs to be done into our existing database, apart from updating some data into our microservice database. Yeah, moving on to the next slide. So in the last few slides, we have already discussed about the gateway that we have integrated, how it's actually going to redirect the request into our microservice and let other requests to serve into our backend monolithic system. So obviously, we understood that there are so many things that can be customized using a gateway, which may be a bit tricky if we try to do that using an internal load balancer or any kind of load balancer inside a cloud system. So, and obviously the centralized authentication system can be implemented into a gateway. Suppose, say for example, if you want to validate a request, whether it's authorized or authenticated, even before sending that request into a particular backend or microservice, you can obviously have the option to do the authentication into the gateway part. And also you can do customization of your incoming API request. You can add new headers or modify the existing headers if you want to do so based on your project demands. You can do that obviously from there, and you can do that from using code. So for our case, we have used the Oscillate gateway because it's actually good to glue with our existing .NET application, because we are writing the applications in .NET code. And I believe there are so many other gateway API available there as well for cloud system or for your specific project framework related, I believe. So yeah, you can explore that part. For our case, we actually picked up the Oscillate gateway, and yeah, it actually served the purposes that we needed. So this is a bit of the syntax of how the customizations can be done in our Oscillate gateway. It's actually a JSON file. So there are some things or some property which needs to be defined as per Oscillate gateway specification. So here we actually first need to define the downstream part template, that is the incoming request, and for that we can define the host. And with the upstream part template, we can define where the downstream part template request should be redirected to. And obviously you can define all the existing REST methods. So as you can see here, we have defined the microservice related redirection. And in this part or the below part, in below part, we have defined all our existing API calls so that they can be redirected into our monolithic applications. And this syntax may vary depending on gateway to gateway or the gateway that we are using. For Oscillate, this is the syntax that we actually need to follow.
Siam bhai, I do have a quick question in here. So about the Oscillate gateway you're talking about, so will it be one Oscillate gateway for per application, or gateway for all the systems that are under the full solution? There could be hundreds of solutions, but there would be one gateway. Just that
No,
part
there will,
I didn't get.
yeah, there will be one gateway, and the responsibility of gateway to divide or to distribute the incoming request into different backend system, whether the backend can be a monolithic or a microservice or anything. So there will be one gateway, and the responsibility of that gateway to distribute the request into several backends. If that clarifies your questions.
Yes, that clarifies. Thanks.
Okay, so once we actually were able to convert into microservice using the gateway, everything that I have discussed, we actually found some dependencies. For instance, our monolithic application needs to make a call into our microservice. And what we found that if the call for some reason fails, the monolithic application will go down. So obviously we actually need to do some extra checking just to make sure that no downtime happens just because the communication was not succeeded. And there could be some other API calls from your monolithic application to your microservice, and there may be some errors, but we found that with those errors, we can actually live. There will be no hamper into our workflow of monolithic application. The customers will not have any impact. So those things we can live with it, and we actually plan to improve them later. Moving into this slide. So yeah, obviously there were some challenges. So when we actually started importing the code from our existing application to microservice, the existing application is still running into the production. So basically we actually had to maintain two code base parallelly. And obviously during the conversion, there are some bug found into our existing system. So we also had to make some plan that whatever fixes that we do in our monolithic application, those things are in sync with our microservice, because otherwise the microservice will not work as expected once it goes to the production. So yeah, so it's really important to have this kind of plans during your team meeting scrums, so that all the team members are on the same page. And in our team structure, we actually have a data team. They basically pull the data from our database and generate some reports. So we actually had to in sync with them, because previously what they used to do, they actually used to pull the data from our one database. But because we have converted into a microservice, all those, or all not those, some tables have been moved into a separate database. So we actually need to notify them that you, from now on, you actually need to pull those business or pull those data from the new database instead of the previous one, because otherwise their reporting will fail. So it is also important to maintain this kind of transparency with your data team, if you have a data team in your team. But for our case, it was actually really important. And obviously I have discussed that we encountered some situations where we need to make a call from monolithic application to our microservice. So you need to identify how system to system communication will work. If we talk about the microservice system, if we look at the internet, we see that there are lots of technologies out there. You can use the gRPC call, you can use event-based communications, you can use API to API call. So rather than introducing any new thing, we actually need to identify which call would be best suited for our cases. Suppose for some cases, the API to API call was working fine, but for some cases, we actually had to introduce a mechanism so that our microservice updates the data into the centralized database, rather than the monolithic service needs to get the data from our microservice. And yeah, also once we actually deployed the microservice into production, we definitely found some issues. So it is better to have a disaster recovery plan before you are proceeding with your microservice deployment. In our case, we identify like what calls are being made from monolithic application to our microservice. If that fails, what will happen? We have enough mechanism to switch into the old system. In any case, our microservice system goes down. What will be the impact on the data in the production database that we have already synced into our microservice database? So this kind of, it is better to have this kind of planning before you move into the production database, production deployment. For our case, we actually have those and discuss that with our team. And yeah. Obviously, there are something which is actually better not to follow when you initially start a microservice conversion. I would say particularly when you start microservice conversion from an existing system. Obviously, when you start a microservice development from scratch, you will have lots of, freeness or fanciness to introduce so many things. But when you start converting into an existing system from monolithic to microservice, there are some things it is better not to follow, because it happened in our case. So it is advised to keep it simple, even if the query takes 5 minutes. for now, keep it like that and do the performance improvement later by discussing with your product owners and team members how you can improve that, whether the improvement will have any impact into any other systems. And obviously, it is better to stick with what you have, like don't try to update any framework that you are using. Once you start the conversion, you might see that there are some upgrade package available, but once you upgrade the package, you might get some failure. So as a team, we consider whether this upgrade or failure will have any impact the time frame that we had to deploy the things into the production. And when you convert, or when we convert it into microservice, we had a repository, but that repository obviously was imported from monolithic to microservice. So we actually were a bit careful when we actually deal with that part, not to introduce any kind of new things, rather than keep it what we have. And we also initially, when we started the conversion, we did some small refactoring and found that things gets a bit inconsistent. To improve that or to fix that, we may need some more time. Obviously, that might not be feasible with your team or the team members who are working on your existing backend. So it is better to keep a transparency for those things, if whether it will be worth it to do the refactoring or not. So overall, in general, the motivation was we try to keep the things as simple as possible. Whatever we have in our existing thing, just import it into our microservice and see how the things are behaving, and gradually work on the improvement, refactoring, package upgrade, or whatever things that would make the best benefit for that microservice. So our microservice has already been deployed into production system. There are some 1 or 2 small issue, but it has been running for almost 1 month now, and we believe it is running good. So there are some learning curves during our journey. So when we actually deploy the microservice into production, it is better to actually consider some downtime. Like for instance, once you deploy the microservice into production, you need to sync the data from your existing database into your microservice database. But in between, if any user makes any update into your existing database, then the situation might get a bit tricky. So it's better to have some downtime, obviously by discussing with your product owners what is the best time frame when customer does not makes that much of request into a monolithic system. And even if you have some issues after production deployment, it is better to maintain some transparency that we did. For instance, we found a situation that even after the microservice production deployment, an insertion was being made into our existing database, which is supposed to happen in our microservice database. So we obviously had some plan how to recover that, but that things was actually discussed upfront with our product owners and teams and everyone, because different people might have some different feedbacks, because these things has been running into the production system for quite a long time. So this kind of transparency were beneficial for us particularly. And the disaster recovery part, I think I have already discussed throughout the slides. So yeah. So more or less that has been our journey. As I have mentioned, our microservice has been running into production for 1 month till now. And now we are actually looking into the improvements, because during the conversion and based on our time frame, We didn't try to do that much of fanciness or improvements. We just focused on to get the things as like we have in our existing system, and don't introduce any disaster things that might impact into our backend. So the next phase of our development will be to look into the improvement scope and introduce the new microservice patterns or packages out there and check whether those will be best suited for our application. So yeah, that's basically pretty much it. If you have any question, maybe we can bring it now.